We all know how easy it is to spin up an AI app right now. You just need an Anthropic or OpenAI API key in your Next.js boilerplate, sync it with Supabase, and vibe code your way through the UI and launch. But if you're running an agency or a SaaS platform, say something that passes complex legal documents like rent leases, then you know the truth. Prototyping is free, but production is painful. In 2026, the best companies aren't the ones who are using the best base models. They are the ones who have mastered LLMOps, infrastructure management, agentic orchestration, and evaluation first development. Today, we are going to break down the exact system architecture that you need to run an AI company without burning cash or shipping regressions. We are going to cover prompt versioning, agent routing, full trace observability, and cache control. So let's map out. In traditional software, state is predictable. But with AI, your output is non-deterministic. If you rely on a single prompt for all your heavy liftings, your app is going to fail at scale. That's why in modern architecture, companies are using multi-agent workflows. You don't just send your input to an LLM, you send it to a router. The router evaluates the intent, assign the job to a specialized agent, and then send the output to a validation agent. For example, if you are analyzing a contract, Agent A extracts the clauses, Agent B evaluates them against the local laws, and Agent C outputs the JSON format for your Node.js backend. If Agent C fails the schema check, then it loops back. This whole process requires an orchestration layer. Frameworks like LangGraph or custom multi-agent orchestrators lets you easily set up this reliably. Multiple agents means having multiple failure checkpoints. That's where we come to observability. When a standard web app breaks, you check the logs for its failure trace. But when an AI app generates a hallucination or skips a critical step, the generalized logs tell you nothing. You need full input and output tracing. You need to track every LLM call, every tool invocation, and every database retrieval step. If your agent makes a bad decision, you need to see exactly what context was injected into the prompt at that millisecond. Platforms like BrainTrust and LineFuse are non-negotiable now. They sit between your application code and your LLM API. They log the exact token usage, latency, and the full context prompt. And speaking of prompts, stop hard coding them in your repository. In LLMOps, the model is the least frequently changed component. You are not versioning base, you are versioning the prompts. A system prompt that worked perfectly last week might degrade today because the provider silently updated the base model. Every prompt change is a deployment. Your prompts should live in a centralized registry. A developer tweaking a prompt to fix an edge case should just not go live. It should go through a proper evaluation pipeline. Instead of ship and pray, you make golden test sets. Before a PR is merged, your CI/CD pipeline must use a LLM as a judge to score the new prompt against hundreds of historical edge cases to ensure you haven't introduced a regression. Finally, let's talk about margins. If you're an agency that's building tools for clients or a SaaS platform, token cost will eat you alive if you don't manage it. First, allocate every dollar for your AI spend. Use virtual keys or tagging so you know exactly which client, which tenant, or which feature is driving you the cost. Second, you should implement semantic cache. If a user is asking a question that is 95% similar to a question asked 5 minutes ago, then your API gateway should serve the cache response instantly. Zero latency, zero token cost. And route intelligently. Not every task needs the most expensive and the most heaviest model. Use a fast and cheap model for routing and schema extraction, and use the heaviest model for the most complex tasks only. The era of AI as a novelty is over now. We are now in the infrastructure phase. To build a sustainable AI company, you need to treat LLMs with the same operational discipline as traditional databases and microservices. Version it, trace it, evaluate it, and optimize it. If you got value out of this breakdown, please hit the subscribe button. Let me know in the comments which part of the LLM ops stack is causing you the biggest headache right now. See you in the next one.